brief plans. First of all, um, I would be using Python for this project. And second, before I start modeling, I will do data exploration just to make sure fully understand the data and the variables, what type of variables they are there any missing variables, and what are the correlations among all those variables, and how's their relationship with the dependent variable. And then I will move on to data processing and get ready for modeling. And I decided to build linear regression and also use lasso and ridge, also decision tree and random forest. And in the end, I will compare the performance of all those 5 models and choose one that best for me. Okay, let's take a look. In the first initial step, I'm doing data exploration. So my approach is to plot out the variables. I usually start with the scatter plot, the pair plot, so I can see the correlations, the relationships among all the variables and their relationship with the dependent variable, where you can see this row is the PE. Apparently, we're seeing some linear relationship between PE, our dependent variable, and the variable AT, and some strong correlation with the variable V as well. AP and RH, some kind of relationship, but not as strong as the other two. In this scatter plot, we also can tell, in addition to the correlation between my dependent variable and independent variables, there are also correlation among the independent variables, which may cause some multicollinearity issue for me. Okay, let's take a look. Move on to the next. Before I put my efforts in the modeling, I plotted out the correlation matrix just to make sure fully understand the correlations among all the variables. And apparently we can see between variable AT and variable V, there is a very strong positive correlation. And also even between AT and AP, there's more than 50% negative correlation also with the RH. So those are all the warnings, the red flags I would reconsider after the first round try. So let's move on to my model results. By using R, I've built out linear regressions in the lasso and ridge. And if you look at all these 3 regression models, actually they are quite similar. The mean square error are the same, and MAPE Rsq also. They're all the same when I round it to 2 decimals. The major difference would be slightly difference between the coefficients and lasso, but the model performance itself, there's no significant difference. All right, let's move on to the tree model. In the tree model there's significant better performance in the tree models, especially the random forest. The mean square error reduced to almost half of what it was, and the MAPE is reduced as well, and the R-square is significantly improved to 96%. So my conclusion is, if we don't care about model interpretability, out of the 5 models, I would choose the random forest, which apparently outperformed the rest of the models. If we care about the model's interpretability, which means if I can explain to my client what are the impact from each of the input variables respectively, can I can I clearly quantify it, I will have to choose the regression models, which based on the mean square error and the R square is not a bad model at all. But there are definitely some concerns, especially the multicollinearity and some kind of nonlinear shape relationship between the dependent variable and the independent variable. So in the future, if I have time, I would improve my project for sure. I would do some transformations for some of the variables, like the variable v or AP to make the nonlinear ship more linear ship relationship. After the transformation, I can rebuild the regression model to improve it. In PCA, dimension reduction is also another option, but it's not that easy to explain the model after the PCA transformation. Just one thing to keep in mind. And if I don't care about the model interpretability, I would definitely try the neural networks. And that is what I have. Thank you so much.